Okay, guys, I guess we are starting. Quick introduction on myself. I'm Francisco Menezes from OutSystems, which is actually one of the sponsors, but don't worry, I'm not here to sell OutSystems. What I'm actually going to share with you guys is the experience that I accumulated as the head of development and architecture practices using OutSystems. And I think that this experience is quite generic for any technology, and that's what I'm trying to bring to you guys here, so I strip out of any particularity of the OutSystems platform itself. But it's interesting to see that how, with a low-code platform such as OutSystems, you will end up having to worry a lot about architecture, because a low-code platform enables you to generate code very fast. And so developers just run into creating features and implementing features, and sometimes they tend to forget about architecture. And actually, the framework that I'm presenting here is being absorbed by the platform, because we should somehow enforce good practices and lead the development into the right direction. So, what is the mission here is to show you a framework that potentiates IT scales and potentiates continuous delivery. Okay? So let's start. I will start by introducing the 4-layer canvas, which is the framework that we use to map business concepts into software artifacts. Then I will introduce the benefits of domain-driven designs and some considerations about how to develop or design a proper domain API. I will try to then cope with the microservice principles, trying to lighten up a little bit the I would say maybe the myth, because some people just think that microservices is something that we all need to do right now, but we need to have the proper balance and understand when it should be used and not. And I will finish with some recommendations about designing for consistency. So, amazingly enough, the 4-layer canvas has 4 layers, as you see. And although these, you see here 4 layers, it doesn't mean that an architecture is limited to 4 layers. You can have sub-layers inside each layer. But basically, bear with me, each layer represents a quality, a type of concept or artifact that you're building, right? And the main idea, I will explain each layer, but the main idea is that in the bottom 2 layers is where you're going to build all your reusable services. And the top layers, you should not provide any service at all. And you will see why. So we use the 4-layer canvas to help us map the business concepts, and the main idea of a proper layer architecture is to match the business, because if you don't have an architecture that matches the business, it's difficult to evolve the solution further and further more. And this is quite mandatory in a local platform where you very quickly add more and more features to your solutions, right? So let me explain each layer. On the bottom is where you should add all your non-functional requirements, all your third-party integrations, or all kind of goodies that extend your framework. This is not business-related. So let's see some examples. For instance, if you do an ERP integration, even if there is already a service available, there is always space for some wrapping, normalization, and this is the kind of stuff that you keep adding on your foundation. Or if you want to provide reusable UI widgets, being a simple calendar, a progress bar, a complex form, whatever that is reusable, or if you want to, you have a non-functional requirement of audit trailing all your user interactions, or you want to support a single sign-on mechanism, so on and so forth on all your applications, you keep adding this on your foundation layer. The core layer is where you're going to abstract business concepts and service around business concepts, such as a customer, a claim, a contract, a product, whatever. And these two layers are the reusable layers. So here we are not providing end-user interfaces, screens, and so on and so forth, but this is where you capture all your logic. Then the third layer is where you provide functionality to your end users. User interfaces and user processes, and for instance, that's where you identify all your user processes. I need to implement the customer management, I need to implement claim handling, service requests, so on and so forth. And finally, on the top layer is where you're going to implement all your cross-application functionality, typically your access portals, your global dashboards, but it's not mandatory to have an orchestration layer in all your projects or all your solutions, but whenever you have to combine cross-application processes and information, you should identify those. So you end up with a neat blueprint of your architecture, of the solution you're going to implement, but of course, you need to follow some rules. For instance, this one is quite obvious. You should not have upward references. Otherwise, you would be violating the proper isolation of all those concepts. And you should not have side references among end users or orchestrations because they are not supposed to provide services. And this is already a sign that something is not correctly isolated or abstracted. And finally, since you can have side references at the core or foundation level, you just need to pay attention on your cycles, okay? Well, at OutSystems, we developed a framework to monitor this. So as you keep developing stuff, it's very relevant, important to keep an eye on what is happening, because if you spot this instantly while the developers are still hands on the code, it's easier to solve and fix rather than once this is already in production and having to refactor with tables moving around and other complex stuff, okay? Now, I was talking about modules and mapping concepts into modules, but modules don't live alone, right? Normally you have some kind of projects where you create your modules. So these are the deployment units, the ones that you will produce an application or will produce a DLL or whatever, and that you need to deploy somewhere else, right? And the four-layer canvas is applicable to the deployment unit level as well. And basically, what happens is that if you have a project with several modules, the top one is the one setting the level of the whole project. So this is an orchestration project because the top element is an orchestration element. And of course, as before, all your reusable services will be provided by the core and foundation projects. So even core modules and foundation modules inside one of these projects, they are meant to be reused only inside the project, right? Okay, and the top layers, it's where you create end-user applications. The same rules applies at the deployment unit level, so you should not have upward references, no side references, and no cycles, okay? Now, with this approach, you design by concept, you abstract concepts, and not by technical layers. You optimize life cycles. If you keep these rules, if you follow the rules, you will optimize life cycles, promote abstraction and autonomy, and it will facilitate evolution. Every time I need to change something, I know exactly where is the core of that concept, where is the process that I need to change. I know each level, right? Now, so I talked about modules combined in deployment units, and that's it? No, there's an extra level, which are the domains. So domain-driven design is a methodology and process prescription for development of complex systems that focus on mapping business process within a problem domain into technology artifacts in a solution domain. And so domains, when you're facing with large ITs, large complex solutions, you have to start splitting stuff into loosely coupled domains, each one with its own pace and with its own continuous delivery life cycle. And you should make sure that there are minimum impacts across domains. So this is a divide and conquer strategy, and there are a few considerations in order to properly design domains. Back in the 1960s, Melvin Conway already observed that organizations that design systems typically copy the communication structures of the organization, right? And this is very important to keep in mind, because when you're creating your domains, what is the criteria? What are the aspects that you need to follow in order to ensure that the domain independency, right? The first one is you should group concepts by functional areas or line of business inside of domain. You should not mix two different domains in the same, two different type of knowledge, like financial knowledge and human resource knowledge in the same domain, because if you do, you don't have so much business fit and decision power, right? The second aspect that is very important is to dedicate a multidisciplinary team to each domain. That is from front-end development, back-end development, querying, very sophisticated UI stuff, even DevOps. You should try to have as much as possible in your domain, inside your domain, so you can actually be independent. And you can actually promote a continuous delivery pipeline in an efficient way. And this also promotes ownership and control. Finally, and that's the obvious one, you need to establish light and very stable service interfaces between domains to decrease impacts across domains. Now, mapping these concepts into IT concepts. So you have the domain, which each domain, like in this example, a human resource domain, a marketing domain, a financial domain, or any other criteria. Each domain has its own independent life cycles. This corresponds to a CD pipeline. Inside each domain, you might have subdomains. You have distinct sub-processes inside, right? And normally, each subdomain, in this example, in the financial domain, you can have this general ledger process, purchasing, salaries. They typically map to a deployment unit or to an application that you need to build. And finally, each of these processes need to handle business concepts, and those concepts are implemented in modules. So you have this hierarchy of modules, deployment units, and pipelines, and CD pipelines, which is a perfect match to the domain-driven design. Okay? Now, what type of domains you typically set in a software factory or in IT? Well, the main domains are the vertical domains that support, each domain supports a line of business. But beneath, you have horizontal domains to provide shared, reusable, and shared services across all these verticals. And on top, you might also have domains to support the global journey of your users across multiple verticals. Many times in your company or on your customer company, you have to implement workflows that involve different departments, that have touch points to different, or even you might have to orchestrate the workflow itself at a top level, right? Now, how to implement services across domains? Of course, you have the old monolith architecture, which obviously you are already thinking, why is he talking about monolith architecture across domains? But I will try to explain why I want to bring this one. And of course, this is like the obvious solution. You should loosely couple across domains. Only REST APIs are consumed across domains, right? But let's see the advantages and disadvantages. If you have a monolith architecture, this is the minimum rules that you should keep. Since you want to have independence among verticals, they should not consume each other, and so you only have strong references to the common horizontal domains. This has some advantages. One is in-process communication, so everything is compiled together in a single binary, a single process. You can also share the same database, share the transactions. And somehow this also adds some productivity because you have access to all kinds of objects. It's not just a REST API. You can even support your very complex objects that can be reused, right? But of course, this type of strongly coupled architecture creates very strong dependencies. And remember that each domain is probably owned by different teams. So you have all these dependencies among teams. And whenever you need to deploy something, this gets in the way. So the main advantage is this increased release cycles. And you get much more complexity on the horizontal domains because these domains cannot provide services. You have to push everything to these horizontals. With a loosely coupled architecture, you can provide service and you can do you can make references in all directions, with some limitations on the upward references because they should be limited to notifications or events. But you have all this flexibility, and now you can provide some services even at the vertical level, because if they are business related, probably they don't belong to one of these horizontal domains. So you have independent life cycles, which is the main advantage, but now you have to face different database transactions. You have to handle different database transactions. You have the inter-process communication, and you have less productivity because now you are always dependent on some API that the other domain needs to provide me, right? And you don't have data sets to aggregate it, to join, and so on. So the idea is to keep the best of the two worlds. And the best of two worlds, it's use strongly coupling inside the domain because this is controlled by the one team, the same team, so there are no lack of control on the dependencies. And of course, this will benefit the very tight processes that are implemented inside a domain. You have in-process communication, and you don't have to worry about multiple database transactions. Now, when communicating across domains, what I'm proposing here is a mixed coupling across domains, whenever possible. Sometimes this is not possible if the domains are in completely different infrastructure, but even then you can adopt at a certain point, at a certain level, you can adopt this approach. So what is the mixed coupling? You have two flavors. One is you have a strong coupling with a query model. So each domain provides a domain API, and this domain API provides a query model, and these are like database views with stable data, with stable structure. So this is summary. This is not we are not providing here all the internals of this domain, but just minimum that don't change so much in terms of structure, but that will allow other domains to list, search, and even match up information from different domains, okay? And this is very powerful because it allows you to do much richer information handling on all the all the consumers because they don't depend on the availability of specific APIs to get me this data, get me that data, and the APIs will give you data in memory, right? With these views, you can actually use the power of SQL language, and you can mash up information. But the important thing is that this is just a summary. So this is a public read-only view of whatever you want to export. And when I say summary, for instance, because I don't need to handle details here, I just need to find me all the customers with this type of contract. Maybe I need to mash up 2 services, right? I can do it, and later on, when I need details, then I use the Service API. Service API will be used for providing data transactions and retrieve detailed information. This type of approach, in my experience, it has proven to be very efficient because you do applications with a nice UX. You're not dependent on constant calls amongst different domains, different servers, and so on and so forth. And the fact that if you carefully choose what is the public view, you don't have to keep changing it so much because the big changes are in the insides, in the guts of the domain. They can change whenever they want, but this is not impacting those public views, right? So the domain architecture, the way you provide the domain API, so you have a consumer here, you provide a service API in a query model. The common model, and as you might have probably understood, I'm adapting a little bit to the common and query key. How does it? Responsibility segregation. Thank you. I got a blank now. So this is an adaptation of the query and common responsibility segregation or something. But of course, your common model is spread across the insides of the domain. But the query model is the public view with the summary information, right? And then you have the service API to provide transaction, fetch details. Of course, you should take a lot of care about the evolutionary design of these two, because these should evolve only with non-breaking changes. With this approach, you have data isolation, ownership, and you reduce impacts. This arrow on this direction, this is just another idea, because sometimes instead of a view, you could even have a hot cache or something, but these guys must synchronously update the query model, so you don't run into data inconsistency, okay? Now, talking about microservice principles. So I haven't talked about microservice so far, but of course you already see some of the flavors. And the microservice is, for me, it's basically a natural evolution of service-oriented architecture, forcing some principles that are very useful to avoid you running into a lot of known bad patterns and problems. And But the way I see this is that, and as I explained before, inside a domain, you don't need microservices. You don't need to loosely couple. You lose a lot of capacity. But across domains, this is important, right? So the way people typically perceive microservices is any black box giving me a service through a REST API is a microservice, right? They might be compliant with all those principles or not, but that's how I see it, because they are providing me a REST API. Either you simply have a service project that provides a service API and you can comply with the basic principles, or you adopt a domain structure, which means that you're adding the product, not project, because now I have here a team that is giving me a product. It has decentralized governance and decentralized data management. And you can even go further and do some infrastructure automation with containers and so on and so forth. And you can follow all the principles, right? And my key point here is that you should not be fundamentalist on this aspect. Whenever possible, you should expose a query model, because this is highly beneficial. So besides the service API, whenever possible, you add a query model. And of course, the domain API, such as this, will have the microservice principles plus data composition for productivity and performance. Okay? Now, what is the correct service granularity? Well, as you know, in microservices, size doesn't matter, right? So you can have a simple service project, or you can have the result of an entire domain exposing an API. The second criteria is that you should leverage independent lifecycle. So even though all these services belong to the same domain, you might have consumers using them independently, and they don't have too many dependencies, so you are actually exposing different APIs, and they are perceived as different microservices, even though they are sharing the same database, right? Now, the third, for me, it's one of the most important criteria to correctly separate microservice is the transaction part. You should merge services requiring the single transaction. So again, you have 3 services on the same domain. And of course, this is a consumer, so it's going to create a customer, and given the customer ID, will create a contract, create an account, but you have to add a lot of extra code if some transaction fails. If the second fails, you need to backtrack the first one. If the second fails, you need to backtrack the other 2. If you have a chain of 6 or 7 or 8 service calls, you see the mess, right? So merging services is not a solution, because you keep having different REST calls, different processes being created, so different transactions. What you need to worry is when doing service design is to create single transactions per use case. If I have such a use case, I should not leave, of course this is a bad name, just to make it clear what it's doing. I should not leave the control to my consumer, because I'm providing the service. I should have all the intelligence. So I should design my API supporting all the use cases that my consumers might require, right? Now, what if services can't be merged? Because they belong to different domains, they are in different infrastructures, different environments, whatever. And as we have seen, chaining services synchronously creates a complex composition. So we want to avoid that. So the key message here, is trying to avoid that inconsistency rather than fixing it. Like Albert Einstein once said, geniuses prevent problems. So let's be a little bit more genius. And the idea is to decentralize control and simplify service composition. So I actually have to chain these calls, but what I'm going to do now is that the first call needs to be synchronous, because I need to get an ID to pass to the other services, but I'm not going to try to make sure that the customer is created. I'm going to create the customer in a pending state. Right? And the remaining calls now are asynchronous requests. Those services will support some kind of queue, and so this doesn't fail. I just enqueued my request, and these are treated in background. To regain consistency, you can use notifications. And every time, once the account is finished, it can notify, let's say, the customer, and the customer can react and update in his internal state. Of course, now, your consuming application can list, can mesh up all this information, can list closed, pending, erroneous processes, and of course, now your application should account for asynchronous processes. It's no longer the situation where the user clicks in one button and he waits, and probably waits and waits and waits synchronously until he gets done or an error. The UX must account with the fact that this is going to be handled, and you will, and consistency will be automatically fixed. Now, this approach has another problem, because now I have services having to know which one to notify. So the generic design is to use events to further decouple services. So I simply publish that something happened, and whoever is interested will consume and act upon it, right? Oh, this was fast. I guess we have plenty of time. I'm sorry, I talk too fast, right? So just to summarize the main messages here, you should follow sound foundations. You should set your domains properly. You should adopt light APIs with data views and comply with microservice wisely. It's not something that you need to adopt for all your interactions or all your communications among sub-processes, but you need to know when to use it. And of course, design for eventual consistency. Nothing needs to be done synchronously and immediately, okay? I guess that leaves a lot of time for questions and answers, because this was my last slide. I'll be glad to share any experience if you want. This gentleman over there.
Yeah, next presentation. Maybe I missed it. How is it? Is it the C4S pattern? So this looks very similar to...
Yes. You mean the well? So the question is if this is the I'm having a problem with the pattern now. Common and query CQRS. Oh, CQRS. Well, it's an adaptation of the CQRS, right? Because the CQRS actually it's implemented with REST APIs only. I mean, with loosely coupling. You have an API for writing and another one for reading, or one for doing the operations, right? What I'm proposing here is that the part of the reading, so the service API can be even split into subparts, one for writing and another one for reading. But the query model is something that you can autonomously, as a consumer, use, so you don't depend on that service. Because what happens is, if you don't expose some kind of data set, every time you need something, now I need to filter by region. I need to make sure that the other ones, the API gives me the possibility to filter by region or by different criteria. And the fact that now I have all my domains providing me those query models, it means that now I can, let's say, get customers from one service and aggregate or join with service requests or claims on another service, right? And actually, whenever that's not possible, because, for instance, exposing some view, it means that you have a strong access to that database, right? Being a view or being even a hot cache, right? But what another pattern that we typically do is that sometimes the same team that is responsible for providing the service, you will provide a proxy that you can install in another environment, and that proxy is doing the synchronization of the summary data, and for the consumers on the new environment, it's the same microservice, right? It's the same microservice that is providing a service API plus a query model. But having a query model is always very handy. And what I've seen from my experience is when you don't have one, you have a lot of strong dependencies with the other domains, the other providers, because you need data in different ways. And mostly because you need to mash up information. It's not only about getting information from that service and then information from that service. You need to mash up information, right? I should have put that pattern because there was time. Yes?
The question is slightly related to what we're discussing now. So I've been in some situations where we haven't done it without query model.
Mm-hmm.
We provide service interfaces.
Mm-hmm.
And then what happens is either we have to dump everything in the response, so all clients are satisfied,
Mm-hmm.
or we have to update the endpoints continuously and satisfy all the customers
Yeah.
incrementally. The concern that I have with the query model is if, for example, we give SQL interface or whatever, this can have important performance implications if they don't use it correctly. So
Okay.
have you used any tool to enforce that in some way, enforce best practice.
Yeah. But if you require some isolation or protection of your domain, that's where you can do this. The query model is not a view; it's actually a cache of summary information that you are updating because you don't want your consumers to interfere with your internal database, right? So that's one way. And actually, in this query model, as I was saying, sometimes if they belong to different environments, different infrastructures, you're replicating this to another place, right?
So that they cannot affect like the production.
Exactly. So you're not required to replicate. You can just provide a view on your data if you know that this is a controlled access, or because this is not public for every other domain. You're just providing this for a certain domain, and of course. But yes, that's a good point because that's often the case. And actually, when you're doing some kind of cache, you can even implement it like a hot cache because you can keep house cleaning that cache, so you just keep the hot data, the stuff that is required right now, not old process and so on and so forth. So it gives you an opportunity to provide a very efficient set of data that is always cleaned up. Because here you have to keep everything most of the time, right? Of course, you can archive and so on, but yes.
So I'm correct in understanding that the thing that distinguishes the orchestration
Uh-huh.
from the other endpoint layer is that the orchestration layer involves potentially more spread out subsystems or microservices than the ones that would be in the endpoint layer?
Yes, sometimes yes. Because on the orchestration layer, for instance, let's imagine that you are implementing your portal where you create customers, but then you have to also follow all his requests and so on and so forth. And the customer provisioning probably is provided by this application. The claim handling is provided by another application. But you have a portal that somehow gives a unique experience, and at a certain point, you're jumping, and this is loosely coupled because it's URL based, right? Now, the problem is with the logic. The logic, you need to actually perform something, but you don't put too much logic here in this type of application because the transactions will be performed. So if I want to, I can access my portal, but then I will be jumping to this functionality to actually provision a new customer. So the strong logic is here. But here, there's a lot of, for instance, this is where you design your own pages for different roles. So if I am a manager, I will see a screen with all my important approval process in different applications. It's a mashup of information. But once I click in one of the processes, I'm already jumping to a specific application, right? But meshing information is one of the key aspects. And, that might not be the case. Of course, this was the result of architecture in our systems. And for instance, another need that we have is that we implement processes. And sometimes you might have a process here, let's say to provision a customer and another one to provision an account. But you might want to have a global process that orchestrates everything, right? That's another place to. And of course, sometimes this is. They might all belong to the same domain, because if this is all customer relation stuff, the portal probably is also customer relation. So they all belong to the same domain. And then what I'm saying is that in the same domain, you can benefit from strongly coupling, right? The drama is when you have stronger coupling across different teams, right? I think we are all done, or? Okay, guys, I'll be at the OutSystem booth, so if you have any further question, just look for me, and I hope this was helpful for you guys. Thank you.